In this video, we'll see an alternative for visualizing undirected graphical models like the conditional random field, known as the factor graph. We've seen in the previous video that one way of visualizing a conditional random field is to draw a network where each node would correspond to one of the random variables in the model, and then we would draw an edge between each node that share at least one factor in the product of factors form of the conditional random field. Now, one problem with this visualization is that it's actually ambiguous. So we notice, for instance, that we actually have a clique between, and there's a mistake here, this would be x2. We actually have a clique between y1, y2, and x2. So we have a clique like this here that is a subset of the graph where each node, each pair of nodes is connected to each other. And this actually kind of suggests that perhaps there was a factor that had as its three arguments y1, y2, and x2. Because in this case, then I have to draw an edge between y1 and y2, an edge between y1 and x2, and another edge between y2 and x2. But in fact, in my actual model, all I had was three factors, one between y1 and y2, another one between y2 and x2, and another one between y1 and x2. And you know, in some sense, it's as if I had just a single factor, which was the product, so a single factor between y1, y2, and x2, where, which was the product of my simpler factor y1 and y2 times the factor between y2 and x2 times the factor between y1 and x2. But what if I had a model which actually had a factor between these three random variables that was more complicated? It's actually, they sort of correspond to different models. One which is a bit more complicated and can model more sophisticated interactions between these three random variables, and the other one which just assumes that, you know, the way I'm going to model preferences between the values of these three random variables is as a product of preferences between pairs of variables. And so what we'll see is that there's another type of graph visualization which is going to allow us to distinguish between these two cases. So this visualization is known as a factor graph. And the idea is that we're actually going to add nodes in our graph that corresponds to the factors. So in our conditional random field, which is a linear chain and has a context window of radius 1, this would correspond to that, this factor graph. So usually factors, we illustrate them as a little square like this. And now each square corresponds to a factor in my product of factors form of my conditional random field. And now each factor node is going to be connected to its argument, to the random variables that are correspond to arguments of the factor. So for instance, we have this factor here, and it's connected to y3 and x3 because in the factor, which is this, it depends on x3 and it depends on y3. Similarly, I'm going to have this factor here, and it's going to be connected to x2 and x2 and y3 because again, it's a factor that depends on x2 and y3. And so on, say for this factor, and also I have a pairwise factor here, which is connected to y3 and y4 because it expresses a preference over the joint value of y3 and y4. Now the reason why this is less ambiguous is because now we explicitly have the factors illustrated in our visualization. So consider this very simple example where I have this Markov network, which corresponds to three variables, each connected to each other. Like we've discussed before, well, in this case, we don't really know whether it's actually a model where we have three factors that are over pairs or just a single factor over three variables. However, given this factor graph, well, if I was to infer what is the Markov network visualization based on that factor graph, well, I'd have to draw an edge between this node and this node because there's this factor that connects them. So there's one factor that involves the two of them. Same thing, because of this factor, I need to draw an edge in the Markov network between these two variables. And similarly, for that factor, I'd get an edge here. And we see that also this factor graph with a single factor will actually correspond to the same Markov network. So while going from factor graph to Markov network is well defined, inferring from a Markov network what is the factor graph is actually ambiguous. So that's not a well-defined operation. So we've lost less information by drawing, or we're providing more information by drawing the factor graph as opposed to drawing the Markov network. There's still some advantage in the Markov network. It's kind of more intuitive and easier to infer the conditional independences like we've done before, though we could extend that logic to factor graphs. But in all cases, when the information about the factors is not as much important and we're more concerned about showing the independences or dependencies between the variable, often we'll favor drawing a Markov network. But if the actual information about the factors is important, then we'll want to use a factor graph. All right, so this covers the second type of visualization for undirected graphical model, known as the factor graph.